Welcome back to ECE 501B. In this short video, I want to simply walk through a proof of Proposition 126, and we will actually prove this proposition using a contradiction strategy. Proposition 126 says every element in V has a unique additive inverse. To go back to what we've been talking about in terms of our conditional statements, identifying the A statement and the B statement, in this particular proposition, the A statement is really for all V, or pick a V in the vector space, capital V. That's statement A. We pick a V or select an arbitrary element in V. That's really what we're saying in statement A. Statement B is saying there exists, and we could do this backward E, there exists a unique, let's just call it W, that also belongs to our vector space V, such that V plus W equals the zero element in our vector space. So we're trying to find a unique W such that V plus W is equal to 0. Our conditional statement then is if there exists a V in our vector space, then there exists a unique additive inverse W such that V plus W equals 0. And that W again is unique. As we said, we're going to prove Proposition 126 via contradiction. And the contradiction strategy then is to assume statement A and assume not B. As far as we look at the negation of statement B, or the negative of statement B, which now is basically saying, oh, maybe we have a couple of different additive inverses that when summed with any arbitrary V, it will give us the 0 element. Making that assumption of not B, we want to look for a contradiction. So let's go ahead with our proof. And to do this, what we want to do is simply say, let's suppose that V is a vector space, or let V be a vector space. Suppose V is a vector space. And let's just pick an arbitrary element in that vector space, or an object in that vector space, or a vector from that vector space. Let V be an element in V. Then, to make it very clear, we could say by way of contradiction, let's just suppose not B, which really says suppose we have W and W prime, which are different. So let's suppose that we have two different additive inverses. So by way of contradiction, suppose W and W prime are both additive inverses of V. So really here, this is our not B. We are assuming that W and W prime are different. In this statement, are suppose. So suppose W and W prime are both additive inverses of V. We're looking now for a contradiction. Let's start then with one of those additive inverses, W, and let's add the 0 element or the 0 vector to that, the 0 element, but we can rewrite that 0 element as v plus w prime, since w prime is supposed to be an additive inverse of v. So we can rewrite 0 as v plus w prime. Now we can simply use the associativity property of vector spaces and regroup these three vectors in our vector space. Let's now group w with v before we then add it to w prime. But now we've already assumed that w is also an additive inverse of v, which allows us now to say that 0 plus w prime is on the right-hand side, but that's just w prime. And now what have we concluded, or what can we conclude? Therefore, w is actually the far left-hand side right here is equal to the far right-hand side. We've now shown that w is equal to w prime, and that's a contradiction because we said initially that they were different. So here is our contradiction. And in writing this proof, we probably wouldn't state all of this, but I'm trying to get us comfortable with where these steps in the process takes us. So a contradiction, since we assumed w and w prime were in fact different. And because we now have arrived at a contradiction, now we can say, therefore, the additive inverse of any element, and we picked v arbitrarily, so the additive inverse of any element v from our vector space is in fact unique. Since we didn't pick a particular v, we just said let's choose a v, a vector, and that now concludes the proof of proposition 126. We proved it by contradiction. We assumed statement A and not B were true. We went through some steps to try to find a contradiction. We did. We showed that in fact w is equal to w prime, which we initially said they had to be different. There's our contradiction, and that now says then that we have the fact, or that this proposition is true, that every element in V has a unique additive inverse. That's proposition 126.